Hello, my name is Dekel Tankel, and in this video we will walk through the capabilities of PivotalCF Enterprise PaaS. We will start with the operational experience, and here is the PivotalCF Operation Manager, and we install the software on the underlying infrastructure as a service. The first example, we will use vSphere as our underlying IaaS, where we connect to vCenter with credentials and data center names. And we can also define availability zones to make sure that every deployment that we're doing is reliable. In this case, we have 3 availability zones mapped into 3 different clusters and pools in vCenter. We can also define multiple networks. In this case, we have 2 networks in the system, one that will use us for our services and one that will use us for our core runtime in order to create separation between services and components. The second step is starting adding services, beginning with the Elastic Runtime. And the Elastic Runtime we will configure on the core network, and we will have different availability zones, so we'll make sure our deployment can run in more than one zone. Now we'll move into a different infrastructure as a service, which is vCloud Air. You can see that the installed experience is exactly the same. The only thing that is different is that box here, that director to connect to the underlying IaaS. And if we'll click here, you'll see that we have different components to connect to vCloud Air, like our account and our org name and so on. The beauty is the rest is exactly the same. All of the services that you add comes from Pivotal Network, and you can see the list of those services here on the website. There is a large selection of services from Pivotal and from partners. In this example, I've installed Cloud-based Jenkins for continuous integration that we will use in the demo, RabbitMQ, MySQL, and other services. Now, once we're done with the install and we have those services up and running, let's switch to see how the developer experience will look like. So this is the PivotalCF Developer Console. We have here an org called DECT line of business. An org will usually be a big line of business or a project within your organization. And that console is pointing to the PaaS that we just installed on vCloud Air, where we basically defined that endpoint here in the Elastic Runtime Cloud Controller endpoint. So that's how our cloud operation team basically said, here is the PaaS and here is how I expose it as an API endpoint. That cedemo.fe.gopivotal.io will be the same endpoint we'll use in a minute when we'll push applications. So within that org, we have 5 spaces. A space is basically a logical entity that can have any name that you want and a group of associated users and services. So it's just a name. And you can control at the org level, assuming you have permissions, all the members of the organization, each one of them. Can they push application? Can they be a space manager, a space developer, and so on. We also have LDAP integration that allow you to do that without manually enter all of these parameters. Now, in this example, we have 2 kinds of spaces that we've seen customer using that paradigm. Again, a space can be anything. So one paradigm is different life cycle of the application, development, testing, staging, and production, for example. And another is for complicated or composite applications that have multiple components to them. What we will do now is we will first push an application into the development space, and then we're going to promote it using Cloud-based Jenkins, automatically using a CI system into the testing space. So in order to push applications into Cloud Foundry, you have 2 ways of doing that. One of them is the Eclipse IDE, where you can just remember those spaces, dev, test. Here I also have a public instance of Cloud Foundry running on Amazon. So the beauty of multi-cloud is your users really don't care where it's running. All they're doing is they can drag and drop into one of those spaces and run their application. The other method is the Cloud Foundry command line, and that's what we will use in this demo. So in order to push our app is a retail demo app that has, it's combined of microservices, and it's using a RabbitMQ message bus to connect between them. So let's create that service. Creating a service in our development space is as simple as going here into the marketplace. If you remember those boxes here that we had as part of the operational view, right? The Rabbit, MySQL, Redis. Here they are now in the marketplace. And we'll call it message bus dev. Okay, now we're ready to deploy the app. And let's go to the command line. So there are 4 things you need to know about pushing applications to Cloud Foundry. The first one is target. Where am I connected to? In this case, I'm connected into this CF demo CE API endpoint, which is running on vCloud Air, but for the exact same way it could run on vSphere or AWS. I don't know, and I shouldn't really care as a user. I'm in org dev line of business and in the space development. And the second command is CF push. Let's see what happens. We're now pushing an app from scratch, from just a WAR file, into a full running application without wiring any middleware component and without starting any virtual machines. If we look here at this environment, you do not see VMs, you see applications and services. It's the PaaS responsibility to start your app in the appropriate container somewhere in the clusters of virtual machine. You do not start a VM when you're pushing an app. And let's see what we're doing here. We are following this simple manifest. This is a demo of an app that has microservices. So we have a producer, that's our first app here, and we have a UI, that's our or a mapper, which is our second app, and they're both sharing the message bus service. But that is all the configuration of that application. There is no connection string into where message bus dev lives or to even what type of services it is. It's abstracted using environment variables. And let's see what happened here when we push the app. We are now downloading the first application. So we are using 8.4 megs, that's our source code, and what we're running for execution, that is our 47 meg. And everything that happened in between here is defined by the Java build pack. That's the assembly of the app, all the runtime components that you need. And we see that pretty quickly the second app was started, that's the UI app, and using that build pack. And if we'll scroll up a little bit, we see that the first app was also deployed using a slightly different commands because it's a different kind of app. The first one of them is Spring Boot, and the second one is Maven controlled. So now we have the app running, and if we'll click refresh here, you'll see that we have those 2 components here, and I can just click the UI, and I have a full operated application. This is a nice little heat map of retail, demo of retail traffic across the US. Fully operational, running in a live URL on our private or dedicated CE demo environment. Now let's say that we are happy with that application. It's running, it has 1 instance each, and we want to move it to the next phase of the life cycle. Now we don't need to call anyone and provision 3 weeks to provision an environment. What we'll do is we'll basically use Jenkins to push the application to the next level. So here is Jenkins. In order to log, you see that the same user that I logged in here, Dekel, is also my Jenkins, my enterprise Jenkins user, and it's running on the URL of my private PaaS. So everything is configured for me when I deployed that tile, and I have a fully functional environment. And now let's go to that retail demo project that I created here. We'll log in again because we timed out. So in a nice example of the single sign-on. And we'll click the project. What we configured here is simply going to a get URL, taking the branch that is the microservices branch, compiling that code and adding a post-build steps. Those post-build steps is essentially the integration with Cloud Foundry. In this case, we've logged into the API endpoint of CE demo with to our org with the space testing. So instead of logging into the space development, now the CI system will log into the testing space and promote the app. In this case, we are logging only with the QA user, which is the member of the testing space. And we're doing a push. That's basically it. So that's all it means in order to promote an environment or promote an app. And let's click the build. And again, there is everything comes integrated out of the box. A very important value proposition of Cloud Foundry, of PivotalCF, is that you do not need to deal with integration between services. In this case, when I configured and uploaded the CloudBees Jenkins tile into the system, everything was configured for me, including that single sign-on that allowed me to just go, click that URL here, Pivotal CloudBees dot whatever environment I'm setting it up on, and immediately push applications. Now let's go and look at that project for a minute and see what happens here. We'll go to the console output. And what we can see, remember this looks familiar? So we build the app, we targeted an endpoint, and we push both instances. Everything happening directly from the CI system. And if we'll go now into our testing environment, now it's testing space. Previously we didn't have any application, and now we have both running applications promoted, this time in 2 instances as I requested, from our development environment into our testing environment, automatically based on a successful nightly build, for example. And you see that now the app is running with 2 instances. Let's move on to demo additional capabilities. We'll go into the production space now. And here we have our same app that we know from before, running in production, connecting into 2 different services this time. Let's click that URL, and we have 5 instances running. And what we're going to do now is we're going to kill one of those instances. So 2 a.m. at night, something bad happens, one of your production instances dies. Let's see what actually happens. We'll click the application itself, and we will look into the real-time dashboards that we have here. So you see that instance is now down. One of those 5 instances is down. But the platform automatically restarts or starts another instance. Now it's in starting. That happened automatically. And the application never goes down. So here is our app. It's still running. You see everything is streaming and changing. We lost 1 instance. And in a few seconds, we'll see that the self-healing is completed. And we're now back to 5 running instances. 5 running instances. This one is still starting. Let's give it a few more seconds. And the app is healthy again and running with 5 instances. So again, self-healing, no individual manual intervention from anyone in the process. Let's demo also scaling now. So let's look at this simple scale app that basically prints a certain state of the app, including the instance that it's running in, how much memory, and so on. And now we're going to take that app and let's scale it to 100 instances. So we're starting now 99 more instances of that application. We are not starting now 99 more virtual machine. We're starting 99 additional container across the 5 VMs that we have from our Ops Manager experience. And you will see that now those instances are already starting. And in a few seconds, we will have 100 live instances of that app running. Very quickly that this thing is going to happen. And if we'll go to the app itself, we already have some of them running. Let's give it a few more seconds. And we will see that we have the other one running. And if I'll go to the actual app and start clicking refresh, you will see that the instance count changed here, and we're actually load balancing between different word and container ports. Those are the ports that the app is running inside the virtual machine. So you see that we are switching VMs and IPs. Sorry, we're switching containers and IPs, and we're also switching instance number. So we're load balancing between all of those instances, and I didn't have to go here and reconfigure load balancer, submit a ticket to someone to do this manually, dynamic load balancing by the system. Let's get back to Ops Manager now. And we scaled to 100 instances, and now we're using a lot of our capacity. So our Cloud Ops team actually wants to scale the entire cloud, add more resources. Remember those 5 DAs? Let's change it to 7. Let's increase our cloud capacity as operational people now. We'll put 7 here. We'll click Save and Apply. So what's happening now is that the system will actually start 2 more virtual machines in the vCloud Air environment, 2 new VMs. And while it's doing, I will not need to log into each one of those VMs. Let's ignore those errors. And let's start the installation. And while this process is happening, while we are scaling the virtual machines and adding more capacity, our existing applications, here is an example of the one of our retail demo, they're just going to run. There is no downtime happening while we're doing that. So we are now going through all of these steps through the services that we have, automatically logging into the VMs. The underlying engine of PivotalCF is going to configure all these VMs and start 2 new ones for additional capacity. And while all of that is happening, our apps are running. There is no downtime, no more next Thursday, 2 a.m., shut down the system for 72 hours because we're doing an upgrade. This is continuous delivery. The application is running, the console is running, everything is green. Our CI system is keep pushing application while we're updating the entire cloud. And now we're actually going to go and add more VMs here and have 7 VMs instead of 2 for additional capacity. And thank you very much.